Hi everyone, welcome to Numeriq Learning. So in today's video, we will be solving the NCERT exercise questions of class 10th. To start with, this is the first video of the playlist wherein I will be solving all the problems of all the exercises chapter wise, and do remember that if this video was useful to you or if you found it helpful, please do consider subscribing the channel and do like this video. So let's begin. So this is exercise 1.1 and the question is you have to express each number as a product of its prime factors. What do you mean by prime factors? The prime numbers are those numbers which will have only two factors. Okay, prime numbers are those which will have only two factors. One is the number 1 and the second one is the number itself. So these are prime numbers and you will have to express each of these numbers as a product of the prime factors. So the prime numbers start with 2, 3, 5, 7. These are all prime numbers. 11 and so on. 13 is a prime number. But if you take on the other hand, prime numbers will always have two factors. If you have more than two factors, that becomes composite numbers. Okay, so let us express the first one, 140, as a product of prime numbers. Okay, so you have to do the factorization of 140. Start with the smallest prime number 2. So 2 sevens are 14, add a 0, again 2. Okay, so 2 threes are 6, 2 fives are 10. Okay, and then 35 is not divisible by 2, so we go with 3. 3 is also, so 5. Okay, 5 sevens are 35 and 7 is a prime number, so we stop here. Right? So according to, there is a theorem which is called as fundamental theorem of arithmetic, which means that every complex number can be expressed as a product of prime numbers, and that is unique for every number. So for example, I can write 140 is equal to 2 multiplied by 2 multiplied by 5 multiplied by 7, right? So this I can write it as 2 square multiplied by 5 raised to the power 1 multiplied by 7 raised to the power 1. So you have expressed 140 as a product of primes, namely 2, 5 and 7 respectively. Okay, so this is what is the answer for the first question. Now let's move on to the next one. These are all complex numbers. So 156. So the second question is 156. So again, let's do the prime factorization of 156. Start with the smallest prime number 2. 2 sevens are 14. And then remainder is 1. 2 8s are 16. Again start with 2. 2 3s are 6. And then 2 9s are 18. Then 3, 3, 1, 3 into 13. And 13 is a prime number. Okay. So 156 can be written as 2 multiplied by 2 multiplied by 3 multiplied by 13, which is nothing but 2 square multiplied 3 raised to the power 1 multiplied by 13 raised to the power 1. So in either ways, whenever you have a combination of 2 square into 3 into 13, it is unique for, so it can only be equal to 156. It cannot be any other number. So for every complex number, the order in which the product of primes, these primes, right? This product will always be unique for a specific number. And it does not matter in which order you write. You can even write this as 3 into 13 into 2 square. In any order if you write, it doesn't matter. Okay, so the order of writing the primes does not matter. Right? So this is the second one. The third one is 3825. 3825. Let's go ahead. 3825. Okay. Let's see if it goes with 3. So 3 1s are 3, 3 2s are 6, 22. So 3 7s are 21. Again 5. Okay. And then again, let's try with 3. 3 4s are 12, 3 2s are 6, and then 3 5s are 15. So I'll try with 5, okay, because it ends with 5. So 5 8s are 40, 5 5s are 25. Again with 5, 5 1s are 5, 5 7s are 35, right? So 3 8 2 5 can be written as 3 multiplied by 3 multiplied by 5 multiplied by 5 and 17. So I can write it as 3 square multiplied by 5 square multiplied by 17 raised to the power 1 or 17. Okay, so this is how you have expressed this as a product of its prime factors. So these are prime factors. Okay, these are prime factors. Now let's move on to the fourth question. What is the fourth question? 5005. 5005. Okay, so 5005. Let's do the prime factorization. Start with 5. 1001. Okay, now let's see if it goes with 7. 7 ones are 7, 30. Right? 7 fours are 28. Again 2, 31. Okay, and then let's go with 11. So 11 ones are 11, and 11 into 3, 33. Right? Now 13 is a prime number. So this can be expressed as 5 multiplied by 7 multiplied by 11 multiplied by 13. Each of it is unique, right? So this is the answer. So you have expressed it as a product of prime factors. Fifth question. What is the last question? 7429. 7429. Let us do the prime factorization here. 7429. So it ends with 9. Now this is a tricky problem because none of the initial prime numbers are divisible for this number, for this specific number. Okay, so here, if think of, if you start with 2, 2 is not divisible, 3 will not be divisible, 4, 4 should not even be used because 4 is not a prime number, and then 5, no, because it ends with 9, and then you can try with 7. So 7429 divided by 7, right? 7 ones are 7, and then 4, 0, 2, 6 are 42. Again, it does not, 7 is not the number. So when you keep trying, okay, now that I know what number it's going to be, so it is nothing but 17. Okay, so you can divide 7429 by 17, right? So if you go ahead, 17 into 4, let's quickly divide it. You can also do it along with me. 7429 divided by 17. So you have 4. 7 4s are 28, 8, 2, 668, right? Here you will have 68. Subtract. So 62 again. So then 3, go with 3. So 3, 7s are 21, 1, 2, 5, 51. Then again you have 1, 1, and then 9. So it's 7. 7 sevens are 49. So it's okay. So when you divide 7429 by 17, what is it that you're getting? 437. Now again 437, you can divide it with 19. So 437 divided by 19. What would you get? So 19 into 2, 38. Again 57. Correct? So you have 3. 57. So it's again 23. So this is a problem which requires you to, it will take a lot of time because none of the initial few small prime numbers are divisible, isn't it? So here this question is a little tricky question, but please do make it a point to not leave it as such. So here the primes are 17 multiplied by 19 multiplied by 23. All of these are prime factors. All of these are prime factors. So this is the answer. So we have completed the first one. So each of it except for the last one, which is like the prime, it takes time, right, for you to you'll have to go from 2 onwards, 2 3 and then 5, you try with 7 and then it doesn't happen, and then you divide it with 11 and then you go ahead with 13 and then 17. Okay, so this division alone will take time, but again you have to try and be fast if such questions come. Next, moving on to the second question. You have to find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. Very easy. So you should find the prime factorization and then find both HCF and LCM, and then also verify that the product of LCM into HCF is the product of two numbers. The first one, so 26 and 91, right? Let us do the prime factorization of 26. So what is 26? So 2 into 13, right? So it's nothing but 2 multiplied by 13. 91, what is the prime factorization? So 7 ones are 7, 3. So it is nothing but 91 can be written as 7 into 13. Okay, so I will change and write here, this is 7 raised to the power 0 and this is 2 raised to the power 0. So here your HCF will be lowest power of the common factor. So for 2, if you see, what is the lowest power? It is 2 raised to the power 0. For 3, there is no 3. So for 7, what is the lowest power? 7 raised to the power 0. And for 13, it is 13. So the answer is 13. And then LCM, you have to take the highest power of all the factors. So for 2, the highest power is 2 raised to the power 1. For 7, it is again 7 raised to the power 1. And 13, it is 13. So you will have to multiply 7 2s are 14 into 13. What is 12 to 1? Okay, 42, 4, 1. So it is 182. 182 is the LCM, right? Okay, now we have to verification. So we will have to verify that LCM multiplied by HCF is nothing but the product of two numbers, that is A into B. Let's verify. What is the LCM? It is 182 multiplied by 13 should be equal to 26 multiplied by 91. That is the two given numbers. So if you see 182 multiplied by 13, 3 2s are 6, 3 8s are 24, and then 56, 6, 3. So you are getting 2366. 2366. Is it equal to 26 multiplied by 91? 18, 19, 20, 21, 22, 23. Okay, again 6632. So 2366. So this is what I get when I multiply, right? So you should also multiply and you can write, therefore LHS is equal to RHS. Hence verified. Or hence proved. Okay, this is how you have to do the other two also. So probably you can try the second question the same way, and I'll do the third one now. So let's do 3, 3, 6 and 54. So I'm going to do the third one. You will try the second one the same way. Okay. 336 and what is the next number? 54. Okay, so let us do the Okay, so let's go ahead and do this question also the same way. So first let's do the prime factorization. Okay, prime factorization of 336. So 336, start with 2, 2 ones are 2, 2 6 are 12, 2 8s are 16, again 2, 8, 4, again 2, 4, 2. 2, 1, and then 3 and 7, right? So the prime factorization of 336 will be 2 raised to the power 1, 2, 3, 4. So 2 raised to the power 4 multiplied by 3 multiplied by 7. Okay, and the prime factorization of 54 is nothing but, so 54 start with 2, 27 and then 3, 9, again 3, 3. So it is 2 multiplied by 3 cube, right? So the HCF of, so whenever you have HCF, you have to take the common factors lowest power. Okay, lowest power. So common factor, so here I will change the color and write here 7 raised to the power 0. So if you see here, which is the lowest power for 2 as a factor, it is, the lowest power is 2 raised to the power 2 raised to the power. So lowest power is just 2 raised to the power 1. So for 3 it is 3. And for 7, the lowest power is 7 raised to the power 0. So the answer is HCF is equal to 6. Now the LCM. For LCM, you have to take the highest power. So for 2, the highest power is, if you see here, it's 4, 2 raised to the power 1. So highest power is 2 raised to the power 4. So for 3, the highest power is among these two, right? 3 raised to the power 1, 3 raised to the power 3. It is 3 raised to the power 3. And for 7, the highest power is, so you have 7 raised to the power 0, 7 raised to the power 1. So it is 7 raised to the power 1. Again, 2 to the power 4. So 2 2s are 4, 2s are 8, 2s are 16. Multiplied by 27, multiplied by 7. So you have to patiently calculate what is 27 multiplied by 7. So 7 7s are 49, 9, 4, 18, 189. Multiplied by your 16, right? So 9 6 are 6 9s are 54, 4 5 carry over, 8 6 are 48, 49 50 51 52 53, 3 5 and then 11. Okay, 9 8 1. So you have 4 12 0 1 3 3024. Okay, so your LCM is 3024 is your LCM and your HCF is 6. Now you have to verify, right? So you should write, we know that HCF of a number multiplied by LCM of any two positive integers is equal to the product of the two numbers. So what is the HCF? 6 multiplied by 3024 is equal to the product of the two numbers, that is 336 multiplied by 54. So if you multiply 3024 multiplied by 6, what do you get? 6 4s are 24, 4 2, 6 2s are 12, 13, 14 and then 6 3s are 18. So you get 18144, right? And then let's just multiply. I'm just going to rub this rough side so that I get some space. Okay, see 336 multiplied by 54. So just a normal multiplication you have to do and just see if it is equal. So 4 6 are 24, 4 2. Okay, so 12, 13, 14, 14 4 1, 13. Okay, just multiply. 5 6 are 30, 0 3, 15, 16, 17, 18, 8 1, 16. Okay, so you have 4 4 1 1 6 7 8 and then 1 8 1 4 1 8 1. Please do multiply it and then make sure you are correct. Okay, so it's matching. So therefore your LHS is equal to RHS, hence verified. Okay, do the second question also. So what is the second question? 5 10 and 92. So for 5 10, 510 and 92, let's do it the same way. And 92. First, let's do the prime factorization. Okay, so prime factorization of 510. So 510 start with 2, 2 2s are 4, 2 5s are 10, 5, right? And then, so 510 10. And then you can go with 3. 3 8s are 24. 5s are 15. Again 5. 5 1s are 5. 5 7s are 35. And 17 is it's a prime number. So you have 2 multiplied by 3 multiplied by 5 multiplied by 17. Then let's do the prime factorization of 92 equal to, let's do it for 92. Start with 2. 2 4s are 8. 2 6 are 12. Again 2 3 23. That's all. 23 is a prime number. So you have 2 square multiplied by 23. This is the second one. Now again HCF. What is HCF? For common factors, you have to take the lowest power. So which are the common factors? Now as usual, I would write. So here I will write 23 raised to the power 0. Let me rub these factorization in order to get some space. And here I will write 3 raised to the power 0 into 5 raised to the power 0. So what is HCF? Taking the lowest powers. You have to take the lowest power. Okay. So for 2, what is the lowest power? Again 2. For 3, what is the lowest power? 3 raised to the power 1. 3 raised to the lowest power is 3 raised to the power 0. Okay. And for 5, 5 raised to the power 0. For 17, again, I think I missed 17. Okay. So 17 raised to the power 0. So for 17, which is the lowest power? Again, 17 raised to the power 0. For 23, 23 raised to the power 0. So all of these values, any number, okay, any number raised to the power 0 is equal to 1. So the answer is 2. HCF is 2. Okay, and let's do the LCM. What is the LCM? You have to take the highest power. Okay, for LCM, you have to take the highest power and then multiply it. So let's take the highest power for 2, right? What is the highest power? 2 raised to the power 2. So 2 raised to the power 2. For 3, it is 3. For 5, it is 5. For 17, it is 17. For 23, it is 23. Now go ahead and multiply. So 2 square is 4. 4 3s are 12. 12 into 5, 60 multiplied by 17 multiplied by 23. So what is 23 multiplied by 17? 7 3s are 21. 1, 2, 14, 15, 16. And then 3, 2. So 1, 9 and 3. Okay, so it is 60 multiplied by 391. So let's multiply it 6. So 6 1s are 6. 6 9s are 54. 4, 5. 19, 20, 21, 22, 23. 23. So it is 2, 3, 2, 3, 4, 6 and I will add a 0 here. Okay, so this is your LCM and your HCF is 2. Now let's verify. So you have to write, we know that HCF multiplied by LCM is nothing but the product of the two numbers. So what is the HCF? 2 multiplied by LCM is 2, 3, 4, 6, 0 is equal to the product of the two numbers, which is 510 multiplied by 92. Okay, 510 multiplied by 92. So let's do it. So what is 2, 3, 4, 6 multiplied by 2? Okay, so you're getting 4, 6, 9, 2 and a 0 here. Again, do 92 multiplied by 51. I'll multiply and I'll add a 0. So again, 4, 6, 9, 2 and a 0. So therefore, you will write LHS is equal to RHS, hence verified. So these are very, very easy questions, but these questions are very, very important that you have to practice these questions. Okay, let's move on to the next question. So the question is, again, find the LCM and HCF of the following integers by applying the prime factorization method. It's the same thing, but it's just that you're given a set of 3. Okay, so let's do it. The first question. Okay, you are given 12, 15 and 21. Let's do the prime factorization. Okay, prime factorization of 12 is nothing but 12 is nothing but 4 into 3. 4 can be written as 2 square, right? 2 square multiplied by 3. Okay, so again, prime factorization of 15 is nothing but 3 into 5. Prime factorization of your 21 is 3 into 7. Correct? So we can put an extra 5 raised to the power 0. 5, we don't have a 5 raised to the power 0. Here you have 2 raised to the power 0, 2 raised to the power 0. Again, here you have 7 raised to the power 0, 7. So wherever you don't have a factor, right? So the first one you have 2 and 3 as a factor. Second one you have 3 and 5. So okay, so 3 is a common one. 2, since we don't have, we added 2 to the power 0. Since the first 12 does not have a 5, we'll add 5 raised to it. So you will make sure each and every number has a common factor. That is 2, 3, 5 and 7. So everywhere you have 2, 3, 5, 7, right? So we have made sure that by adding, anyways, whichever number raised to the power 0, it is 1. So it does not matter, does not change anything. Now let us do the LCM. Okay, so for the first one, LCM, you have to take the highest power. So for 2, what is the highest power? It is 2 square. For 3, look at everywhere. So 3, it's 3 raised to the power 1 here, right? These are all 1. So for 3, it's the highest power is 3 raised to the power 1. For 5, the highest power is 5 raised to the power 1. And for 7, the highest power is 1. So 4 into 4 3s are 4 into 3 into 7 into 5, 35. Okay, so you have to do 35 into 12. So the answer is 420. This is your LCM. And what is your HCF? HCF is nothing but you have to take the lowest power. For 2, what is the lowest power? 2 raised to the power 0. For 3, the lowest power is 3 raised to the power 1. For 5, it is 5 raised to the power 0. And for 7 also, it is 7 raised to the power 0. So HCF is nothing but just 3. Okay, so the question is just find the LCM and HCF. So you have found out. Let's go to the next question. 17, 23 and 29 you have to find. Okay, so number 2, second question is you have to find the LCM and HCF of 17, 23 and 29. Again, a very unique question because all the 3 are prime numbers. So how will you write this? Prime factorization of 17. It's a 17 is a prime factor, prime number. So you will write 1 into 17. Okay, so prime factorization of 23 is also prime number, so 1 into 23. Prime's factorization of 29, it's also 1 into 29. Okay, so what is the HCF? What is the, for every common factor, you have to take the lowest power, right? So it is nothing but 1. Because everywhere else, okay, we can write here, you can write 23 raised to the power 0, 29 raised to the power 0. Here I can write 17 raised to the power 0, 29 raised to the power 0. Here I can put 17 raised to the power 0 and 23 raised to the power 0, right? You can just add it up so that all the factors are common across the 3 set of numbers. So if you see, the lowest power is 1 multiplied by, you have, which is the other common lowest power, 23 raised to the power 0, 17 raised to the power 0 and 29. So it is just going to be 1. And then what is the LCM? Okay, what is the LCM? LCM is nothing but highest power. So you have for 1 it is 1. For 17 the highest power is 17 multiplied by 23 multiplied by 29. Okay, so when you calculate this, let me see what you're getting. So 17 multiplied by 23 multiplied by 29. The answer that you're getting is 11,339. Do check out. Okay, just verify it. So this is the LCM that you'll be getting. That's all. So you have to find HCF and LCM. Let's move on to the third question. 8, 9 and 25. The third one. 8, 9 and 25. Again, very easy. Let's start with the prime factorization of 8. 8 is nothing but 2 cube. Prime factorization of 9 is 3 square, right? And prime factorization of 25 is 5 square. So what do you do immediately? You can put a 3 raised to the power 0 and 3 raised to the power 0 here. You can write 2 raised to the power 0, 2 raised to the power 0 here. You can put a 5 raised to the power 0 and 5 raised to the power 0 here. Okay, to make it convenient for you. Now let's say what is the HCF. For HCF, you have to take the common powers and the lowest power. So for 2, what is the lowest power? 2 raised to the power 0, 3 raised to the power 0 and 5 raised to the power 0. So the HCF is 1. What about LCM? For common factors, you have to take the highest power. So for 2, what is the highest power? Look at the powers. The highest power is 2 cube. So 2 cube multiplied by, for 3, what is the highest power? 3 raised to the power 0, 3 square, 3 raised to the power 0. So the highest power is 3 square. And for 5, it is 5 square. So what is 2 cube? 8 into 9 into 25. Okay. So when you calculate 25 multiplied by 8, okay, 25 multiplied by 8, when you do, you get 200 multiplied by 9. Okay, so 2 nines are 80 and the 2 zeros. So it is 1800. 1800 is the LCM. Okay, so this is how you do it. Let's move on to the next question. Given the HCF of 306 and 657 is 9, find the LCM of the two numbers. Very easy. You should be knowing this formula, that is HCF multiplied by LCM is nothing but the product of the two positive integers. Okay, so the two positive integers are 306 multiplied by 657. HCF is 9. You have to find the LCM. Just apply the formula. So LCM is equal to 306 multiplied by 657 divided by 9. Okay, so you can cancel 3 3s are and then 3102. Okay, and then 657 divided by 3, how much you get? 3 2s are 6, again 3 1s are 3, 27, 3 9s are 27. So if you cut with 3, this is 219. So here you will be getting 102 multiplied by 219. Okay, let's do it. So 219 multiplied by 102. So 2 9s are 18. 3 4, again 0 0 0, again multiplied 1 9 1 2. Okay, so it's 8 3. So it's nothing but 2 2 3 3 8 is the LCM. This is the LCM for the given question. Okay, so whenever you are given HCF and HCF and the two numbers, you can calculate LCM. Or if you are given LCM and the two numbers, you can calculate the HCF. Or if you are given LCM and HCF and if you are given one of the numbers, you can find the other number. So either ways, if out of these values HCF, LCM, A and B, if you know any three values, you can calculate the fourth value using this formula. Very, very easy. Okay, so please do remember it. Okay, so let's continue with the next question. The next question is to check whether 6 raised to the power n can end with the digit 0 for any natural number n. Okay, so natural numbers are nothing but these are the numbers which start with 1, 2, 3 and it goes on. So let's check it out. Okay, so for n equal to 1, right? 6 raised to the power 1 is 6. Right? For n equal to 2, 6 raised to the power 2 is 6 square. 6 into 6 is 36. So it ends with 6. For n equal to 3, 6 cube. 6 cube is 216. It again ends with 6. For n equal to 4, right? 6 raised to the power 4 is, you can multiply and see 216 into 6. Okay. 1296. Okay, so the 1296. Okay, so if you see 6 raised to the power n, okay, will never end with 0. Okay, it will only end with 6, right? So, but in order for a number to end with 0, for example, let us take 60 and let us take the prime factorization. So, you have 230 and then again 2 into 15 and then 3 into 5. So 60's prime factorization will be 2 square into 3 into 5, right? Or if you take 40 or 400, if you do the prime factorization, so 200, again 250, again 225 and then 5 and 5. So for 400, if you see, the prime factorization of a number ending with 0 will be 2 to the power 4 multiplied by 5 square. So what is the common thing that you observe here? That means for any number which ends with 0, the prime factorization will have both 2 as well as 5. It will definitely have 2 and 5. Okay, but if you take your 6 raised to the power n, right, 6 can be split up as 3 into 2 raised to the power n, which is 3 raised to the power n into 2 raised to the power n. Correct? So the prime factorization of n for any n, right, I'm going to write it here. The prime factorization. So this is how you have to present your answers. The prime factorization of 6 raised to the power n will only contain 2 and 3 as its prime factors. Okay. So for a number to end with 0, it should have 5 also, right? It should have 2 and 5. But 6 raised to the power n contains only 2 and 3 as its factors, and we can write 6 raised to the power n does not have 5 as its factor. Therefore, 6 raised to the power n cannot end with the digit 0. Cannot end with the digit 0. Okay, so this is how you have to present your answers. Okay, so here also you can write when you are proving, when you're observing and showing 60, any number ending with 0 is having. So you can write, you can even write here that for any number that ends with 0, its prime factorization will have 2 and 5 as its prime factors. Okay, so you have to elaborate and write this answer. Right? So this is how you have to do whenever you are asked a question of this kind, to check whether 4 raised to the power n can end with 0. You have to check and then you'll have to decide. Okay? Let's move on to the next question. This is again a very good question. You have to explain why 7 multiplied by 11 multiplied by 13 plus 13 and 7 multiplied by 6 multiplied by 5 multiplied, so here, right, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. What are composite numbers? I told you, any number which has more than 2 factors, right? So here, let us take the first number. Okay, so the solution. 7 multiplied by 11 multiplied by 13 plus 13. Take 13 common out. Take 13 common. So what do you get? 7 into 11 plus 1. So 13 multiplied by 7 into 11 is nothing but 77 plus 1. Okay. So it's 13 multiplied by 78. Right. Whatever is the answer for 13 into 78, let's do what is the product. Let's find out the product. 8 3s are 24, 4 2, 8 1s are 8, 9, 10. And then 7 3s are 21, 1 2, 7 1s are 7, 8, 9. Okay, so here you have got 4, 1, 10, 1 0, 1 4. Okay, so this is the product. Okay, and how was 1 0, 1 4 obtained? By multiplying 13 and 17. So this number, for it, one will be a factor, right? One is a factor, definitely one is a factor of all the numbers. And then the number itself 1014 is also a factor. And then you can see 13 is a factor, because 13 multiplied by 78 is 1014. 13 is a factor, and then 78 is a factor, isn't it? So clearly you can see already there are 4 factors. There are more than 2 factors. So you have to write clearly, okay, this, then clearly you can write 7 multiplied by 11 multiplied by 13 plus 13. This expression, okay, has more than 2 factors. More than 2 factors. Therefore, this number is a composite number. Is a composite number. Okay. Similarly, let's do this also. The second one, right? So it is, so the second part is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. You have to show that it's a composite number. Take 5 common. So you will have 7 into 6 into 4 into 3 into 2 plus 1. Right? So if you multiply here, 7 into 6, 7 6 are 42 multiplied by 4, you get 168. 168 into 6, 3 2s are 6. So 48 4 0 4. Okay, so you are getting 1008. 1008. So 5 into 1008 plus 1. Right? This is 5 into 1009. Whatsoever be the product. Okay, so 1009 multiplied by 5. Right? 9 plus 45. So you are getting this as a product. That is 5045 is a product. So again, the factors are, what are the factors? One is definitely a factor. 5045 is another factor. 5 is a factor. As you can see, 1009 is a factor. Again, you have to clearly state. Okay. So clearly, this expression, right? 5045 has more than 2 factors, right? Therefore, this number is a composite number. As a composite number, hence proved. Okay, so this is how you have to do it. You have to elaborate and make sure you're proving that it has more than 2 factors. Okay. Okay. Now, moving on to the next question. Again, a very, very important question with respect to the word problems. You are given that there is a circular path around a sports field, right? Sonia takes 18 minutes. So a circular field, let's draw a circular field here. So you have a circular field, and Sonia takes 18 minutes to drive round the field while Ravi takes. So Sonia takes 18 minutes to complete one round, and Ravi takes 12 minutes for the same to complete. Suppose they both start at the same point A and they go in the same direction and at the same time. After how many minutes will they meet again? At the starting point. So very easy. So what you say is, see, Sonia takes a longer time. Sonia takes 18 minutes to reach, but Ravi takes 12 minutes. So by the time Ravi completes one round, that is in 12 minutes, Sonia would not have completed the first round. Sonia would be somewhere in the, she would not have completed, right? She would have been passed through the first half. So you have to find out after how many minutes will these two meet again at the starting point. Now, one of the major things to think about is, will it be a time less than the given time? So, is there a possibility that the two will meet again at A in 18 minutes, or in 15 minutes, or 16? Is it possible that they meet in a lesser amount of time? That means less than 18 minutes or less than 12 minutes? Not possible, because both have to complete one round in, first one is taking 12 minutes, the second one is taking 18 minutes. So the amount of time that they need to again reach back is definitely greater than the given data, right? So whenever your answer is more than the given data, so whenever your required answer is more or bigger than the given data, then you have to go with, you have to think of multiple, and multiple is nothing but LCM. So you have to take the LCM of 18 and 12. So let's do the prime factorization for 18. The prime factorization would be, okay, 2 multiplied by 3 square. For 12 it is nothing but 2 square multiplied by 3. So LCM is nothing but, you have to take the highest power. The highest power of 2 is 2 square, highest power of 3 is 3 square. So it's 4 multiplied by 9, which is 36. And you have to be very careful about the unit. It is 36. So what was 12 and 18? The unit was minutes, right? So here also you will have minutes. 36 minutes. So after 36 minutes, they will meet again. So after how many minutes will they meet again? So you have to write, Sonia and Ravi will meet again at the starting point, after 36 minutes. That's your answer. So hope you understood. So always remember that NCERT questions are very, very important when it comes to class 10th. You have to prepare yourself in such a way that every solved example and NCERT problem, should have been done by you this year, entire year. In case if you're just starting your class 10th preparation, I'm sure you should be getting an NCERT textbook, and make sure you do every exercise problem, every solved example of NCERT. It's very, very important for your board examination point of view. So I'll stop with this. This is your exercise 1.1. I think we have solved all the questions. In the next video, we will do another exercise. There are only 2 exercises in real numbers. So in the next video, I'll come up with the next exercise 1.2. Hope you understood. And if this video was useful to you, please do consider subscribing and do share it with your friends. Thank you so much.